Hello everyone, this is Rajiv Sanaki, Department of Civil Engineering, Jain Polytechnic, Belgavi. So in today's lecture we will be starting unit 4, that is design of columns and footings. So in this unit we will be covering 3 portions or 3 lectures, that is lecture number 33, 34 and 35. So the content in these lectures are concept of long and short columns, specifications for main and lateral reinforcement, behavior of RCC column under axial load. First, coming to concept of long and short columns. So before knowing that, what is a column? A column is a compression structural member which takes axial compressive force. So it carries a heavy compressive loads. Columns are used or manufactured made of concrete and steel. So in this image you can see circular type of columns. So structurally how a column will be, you can see in this image the reinforcement details of a square and a circular column. So here are some of the examples of columns, different types of columns. So now coming to types of columns. Columns are classified into 2 types, long column and short columns. Short columns are also called as struts. Long column. When the length of the column is more as compared to its cross-sectional dimension, it is called as long column. That is, long column LE divided by R minimum is greater than 50, then it is a long column. LE is the effective length and R is the radius of gyration. So in this figure you can see long columns. Short columns. When the length of the column is less as compared to its cross-section dimension, it is called as short column. That is, LE by R minimum should be lesser than 50. So here in this figure you can clearly understand the difference between a regular column and a short column. Specifications for main and lateral reinforcement. So main steel is provided to resist compression load along with concrete. Reinforcement details. For longitudinal steel, minimum area of steel should be 0.8% of cross section. Maximum AST should be 6% of cross section. Spacing of longitudinal bar should not exceed 300 mm from the periphery, that is the end of the column. Number of bars in column are varying from 10, 12, 14 goes on the diameter. They provide different diameter bars, that is 16, 20, 25. The effective length provided is 48 times the diameter of the bar. So here you can see the structural arrangement of a column. Transverse reinforcement. In order to maintain the position of longitudinal reinforcement and also to prevent it from buckling or splitting, transverse reinforcement is provided. The diameter of transverse reinforcement shall not be less than 1/4 the diameter of the main bar. So here in this image you can clearly see the difference between lateral reinforcement or stirrups or transverse reinforcement and main reinforcement. Behavior of RCC column under axial load. Axial load is compressive load on the column. Axial load of column will depend upon percentage of reinforcement and column size. Axial load of column will depend upon the percentage of reinforcement and column size. In general, columns under axial and concentric loads tend to become shorter columns. that is PU is equal to 0.4 FCKAC plus 0.67 FI ASC as per IS 456 2000. So here you can see a column under axial load. Thank you.